and good afternoon to all. Today I will be presenting some of the machine learning applications, basic introductions, general concept only, and some of recent research on machine learning. And I will be focusing mostly on general concepts only, not focusing much on the mathematical part. So I hope this presentation will be fun. Mathematics will not be so easy, okay? So I am Ashok Pant, graduated from Trivandrum University, and I am currently working as a machine learning software engineer in innovisto. And I have been working for last 5 years in machine learning as a full time. For deep learning, I started my journey in 2014. So here are the basic outline. Here is the outline of the presentation. Firstly, I will be talking about the basic artificial intelligence concept and the basic terminologies we use and what actually intelligence is. I hope most of you already have knowledge about the artificial intelligence, and you have gained certain knowledge previously also, because they have already have very good presentation here. So after that, I will be focusing on the AI problems around us. So you will gain certain knowledge about the AI. Then we will see the machine learning approach to solve those problems. How we can apply the machine learning to solve AI problems. Then I will be talking about certain deep learning concept, why we need deep learning, or why is deep learning here. So after that, I will be talking about some recent achievements with deep learning in the machine learning field to solve artificial intelligence. Then I will be talking about some recent trends of AI, machine learning, and deep learning. So first of all, you know the intelligence. What is the intelligence? Actually talking about artificial intelligence. Artificial intelligence is the thing that mimics human intelligence. If you can design a system, or if you can write a script, if you can write one program that has certain capability like human, that is intelligent system. So what capabilities or what activities are in human that tells us that makes us intelligent? Can you tell me? What makes us intelligent? Very good answer. Decision making capabilities, problem solving capability, and learning capability. Three basic activities of human that shows the intelligence. So artificial intelligence is the same thing in the machine, or in computationally. If we can mimic those activities, then that is intelligence. So here are formal definitions of AI. That it is the automation of the activities that associates with human thinking. Those activities are decision making, problem solving, and learning. Another definition is, it is the field of study that seeks to explain and emulate intelligent behavior in terms of computational process. And third one is taken from one of the dictionary, American dictionary. It is the capability of machine to intimate intelligent human behavior. So these are the basic formal definitions, but intelligent is far beyond this today. So we'll see how it becomes a current recent trend of world, how it becomes the trend today. We'll see later. So how to know the system is intelligent? If the system is intelligent, what are the basic capability of that system here? There is a Turing test for that. It is given by Alan Turing in early 50s, late 50s, and it says that there is one interrogator and there are two players. One is computer and one is human. And and interrogator asks questions to both of them in the written form and do not know the answer is coming from machine or the human. Then the machine is called intelligent. So in real life, are you facing some such during tests? Any of us? CAPTCHA. CAPTCHA, very good. CAPTCHA is the real or the current Turing test for us and machines. It is completely automated public Turing test to tell computers and humans apart. यो तल बिराम साथी छ कोही
यो प्रोजेक्टर सायद तपाईले लिँदाखेरि राम्रो होला यो हार्डवेयरकै प्रब्लम भयो
Okay, no problem. So I'm moving to some of the basic AI problems, toy problems. Up to now you see what the actual intelligence is, the formal definitions only. So now I'm moving to some of the basic toy problems of AI. What actually is AI, or where you can apply the AI, or it is actually can be done with traditional programming or not. We can see that. So here is the problem, the wolf got cabbage problem. The problem is you are on the bank of the river with a boat, a cabbage, a goat, and all. And the task is to get everything on the other side of the river. So there are certain restrictions of this game. You can only handle the boat, and if you are in the boat, there is only one space left to pick element. And third restriction is you cannot leave the goat with cabbage or wood. So this is the very basic toy problem of AI. We can easily find the solution for it. Easily you can apply certain steps, certain transitions, certain deterministic transitions to get things to other side. So it is very simple problem of AI. But when it comes to machine, it is very complex problem. So traditional methods, EPLC methods cannot solve this problem. So we need certain artificial intelligent behavior to solve this. Another toy problem of AI is the monkey and banana problem. Here the problem is there is a monkey at the door and there is a box at the window. And there is a banana hanging at the middle of ceiling, and the task is to grasp the banana by monkey. And this is only possible when box is in the middle and monkey is on the middle, and the monkey is on the box. Then only he can grasp the banana. So this is also toy problem of AI. So traditional program, we can use traditional program to solve this, but here we need some decision making capability, some problem solving capability to do this. And we can define certain state space, certain environment to move on to solve this problem. Another toy problem of AI is traveling salesman problem. Actually, it is computationally very complex problem, but it is very simple toy problem. Here, task is to visit all the cities without repeating and with lowest cost. So it is also one of the common AI problem today. So another very simple problem is the game tic-tac-toe. Here also we need some decision making things to solve this. So now getting to more complex problems of AI. One of the complex problem of AI is the spam filtering. Suppose we have full of large emails. Suppose we are coming from vacation and we do not see the email yet, but now we have lots of emails there, and the task is what are the 20 most important emails for us. So that is the task. So, and what emails are not actually valid for us, or those are spam for us. So this is one of the complex problem of AI. And later we can see how we can apply machine learning to these problems, to solve this problem. Also, you have already have seen how you can do things like this in the previous presentation. Next complex problem of AI is the fraud detection. Here, the customer purchase behavior fraud detection is the task, which is the valid customer and the credit card or the transaction is valid or not. The task is that. Next problem is the movie, songs or any product recommendation. It is very hot topic today, and it is also a very complex problem of AI. So you can see in real life also there are lots of recommendation systems around us, and they mostly use the AI solutions and machine learning. So next problem of AI is designing a virtual assistant for everyone for personal use. So it can help you in the real life by, with your schedules, with your tasks. Another problem is designing a smart home devices. So it can automatically control the home, or the situation can be controlled. You can say that floors can be automatically cleaned, clothes can be automatically structured like that. Next complex problem of AI is autonomous driving. The task is to drive autonomously with the speed of 70 or 80 km per hour along with 120 or 130 km per hour. If you are successful in that drive, then you can say yes, autonomously you can drive the cars or vehicles. It is one of the complex problems of AI today. Another problem of AI is in the medical diagnostic. Here, there are lots of examples in medical field that we can apply machine learning. Or there are lots of AI problems that regular traditional methods we cannot apply to solve them. So we require some of the intelligent behaviors here, intelligent computations here, like cancer cell detection or other classification tasks like disease classification or diagnostic health. Another AI problem is classifying new astronomical structures. There are lots images or objects in the sky, and classify those celestial objects. This is terabytes of data. So computationally, if you go for traditional methods, you cannot do this. Another AI problem is 3D modeling and 3D printing or 3D modeling. It is the task that rendering or modeling 2D object or photographs into 3D models. So it is one of the complex problem of AI. Another AI problem is handwriting recognition. Though it is researched a lot and have good success now, again it is a very complex problem of AI. I have put some statistics here so we can get how computationally complex this is. Before the Spark this presentation, you have seen that if lots of data is there, so we need distributed computing. So how we can get lots of data? You can see from here. If we can take only 8 by 8 image, black and white image, that has 64 representations. So 64 inputs are there. So total of 2 to the power 64 representations or 2 to the power 64 different patterns can be represented with 64 inputs. So it is about 16,000 petabytes of data. And if one pattern, one 8 by 8 image takes 0.1 millisecond to compute, it will take 30 million years to compare all patterns. So it is computationally very complex problem. So we cannot solve this using traditional EPS methods. So we require some intelligent agent here to solve. And here I have put one image here that it is very complex for computers, because what we see is not what the computer or camera see. So camera sees the random independent random numbers, and from that it has to generate some information or the decision. But we can learn directly from the context of whole image. So there are lots of problems in AI. Other problems in the natural language processing are like text classification. That means news classification. Suppose we have lots of news portal in Nepal. If we can write a program that automatically categorize the health news, the political news, the sport news, that is very good thing. So that is one problem. Another is clustering. Clustering means grouping things together. Another is tagging. Tagging means finding most informative word or phrase in the sentence. Another is summarizing. And another most widely used problem is sentiment analysis. And there is question answering. Likewise, the weather forecasting, trend prediction, market trend prediction, or the sales prediction, risk analysis. Like for suppose bank is giving loan to some certain customer, he will examine actually it is risk to give the loan or not. You can apply machine learning here. Forensic problems like criminal detection, criminal activity detection like that, and in surveillance also can use the AI solution, that means machine learning. So we have many problems, so many problems around us, and now we need a system that learns just like a human. So here comes the machine learning. Machine learning actually begins very long ago in mid 50s actually, and then till 90s there are not much attention on it. But at the 90s, after 90s to 2000, there are lots of advancements in machine learning, and till now we are on the top of the technology. That means machine learning is now the top of the technology. So machine learning applies to building computer systems that automatically improve their performance through experience. This is the core concept of machine learning. If we give certain examples of certain tasks, then it will learn to achieve the goal on that task by those examples. So it deals with software implementations that cannot be solved by traditional programming. So if else method or string dot method, this method cannot solve this type of problems. We require some computationally intensive tasks or algorithms to seek the patterns on the input data and to make the decisions. So there are two fundamental concepts of machine learning: induction and generalization from the data. Now everything goes on data, everything goes on experience. No hard-coded design for any of the solution, no hard-coded rules for any of the solution for any task. The algorithm learns from examples. So we need induction and generalization. The goal of the machine learning is to generalize, to find a general rule that explains your data. So we can apply that rule to new data. And now the machine learning is a backbone of AI. If you go for formal definition of machine learning, it is a bit complex, but we can understand it. A computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task improves with the experience. It says it will learn from the examples. It will learn from the data, the input. Then it is the machine learning. If it can learn from, if any algorithm or script can learn from data, then that algorithm is machine learning algorithm. So suppose task is to classify emails as spam or not spam. Now the experience is watching the user either he label that email as spam or not spam. And the performance is the percentage of correctly identified emails. And over time, where user labels email as spam or not, if the system improves the correctly identified emails, then system is said to be learning. So this is the basic concept of machine learning. So hope you have got it. So now, how actually this is done in the computer? How can we apply machine learning to solve AI problems without coding explicitly? Here are the steps. So we have lots of data, image data, video data, audio data, text data. I'm not talking about structured data. Structured data are somehow in a meaningful format, so we can get patterns easily from it. But for unstructured data, it is very complex and hard problem to solve computationally. There comes one intermediate level for machine learning, that is to represent data in the computer, in the understanding form of computer. Then we can apply machine learning algorithm to solve or to find the pattern or to solve that task. So for image, there are vision features. There are lots of features we can extract from an image, like histogram of oriented gradients or pixel density, like SERP, etc. Like in audio, you can have audio features, spectral features like that. In the text, we have US text, named entity text, term frequency line features. And currently there is a word vec model that can transfer your text into the representation, mathematical representation. Once we have all these features computed, then we can apply any of the machine learning algorithm to solve those problems. So machine learning algorithms are general. Only thing is the problem and the transformation at the feature level. That is only the main problem part. But algorithms are general. We can apply same algorithm to classify emails as spam or not, and the same algorithm we can apply to classify news as sport news or health. So algorithms are general. So it is like a human head. We can learn with the same, suppose auditory cortex. We can hear lots of things with a single function, a single model, a single unit auditory cortex. So we can apply same machine learning algorithm to solve lots of AI problems. Only thing is the representation. So here I have put the types of machine learning. There are three types of machine learning. Probably you already have ideas about it. And the first type is supervised learning. In the supervised learning, we know the level of data. That means we know what the class of particular data input is. And in the supervised learning, there are classification and regression problems. I mean, regression algorithms. So regression algorithms are used when we need continuous outputs or outputs in the range, certain range. Classification algorithms are used when we require discrete output levels. Likewise, there is another class of machine learning, that is unsupervised learning. I have seen mostly the supervised learning where we know it, but when you go for unsupervised learning and reinforcement learning, we feel like that we don't know it. Actually, unsupervised learning is only thing that do not have the label. That means we have the data only. Suppose we have the census data, and we have to determine which class of or which place is more educated, more cultivated, more urban, like those. If we have to find such patterns or such clusters from data, then we can apply unsupervised learning algorithms. In the unsupervised learning algorithms, clustering algorithms are mainly there. In the clustering, easiest learning like K-means clustering, expectation maximizes clustering, hierarchical clustering, DB-scan like that. And there is another unsupervised learning algorithm class, that is dimensionality reduction. It is very important and very necessary part of the machine learning, that is dimensionality reduction. When you go for images or audios or text, the data is large, very large dimensional. So we cannot directly compute on those large data, so we have to reduce the size of data to meaningful shorter form. Like it can be thousands of dimensions, but we have to reduce it to 128 or 64 dimensions. So computation can be fast and most of the information still remains there. And the romantic type of learning is reinforcement learning. I tell it's romantic because once you know the reinforcement learning, then only you know the AI. Reinforcement learning actually learns from the example or learn from the experience. It is a model-free learning. You do not require to tell what to learn. If it encounters the situation, it will learn the situation. You have already seen some news on the Google like that. Google robots or Google algorithms are developing their own language. They are talking themselves. Those are unsupervised like learning things. Or there is some supervised learning in there, I will talk later. And in the reinforcement learning algorithm like Markov decision making process, skill learning, time difference like that. So these are basic machine learning types. So here I have put some of the machine learning algorithms to solve the intelligence. Mostly these algorithms are supervised and unsupervised learning algorithms only. I do not put reinforcement learning algorithms here. Like linear regression, where the output falls in, continuous value. Logistic regression, that output falls in certain range. Distant trees, where decision we make with making certain trees structures. Another widely used and most successful algorithm is support vector machine, developed or invented in 1990s, and it draws a hyperplane on the input data, that is a higher dimensional concept. Another very widely used algorithm is name-based algorithm. It calculates the probability of class to classify things. And there is classification with this k nearest neighborhood algorithm. It is also classification problem. And there is one of the clustering algorithm, k means clustering algorithm. And there is random forest. It is actually ensemble of the distant trees to make the algorithm better. And there is dimensionality reduction algorithms. Actually, there are lots of dimensionality reduction algorithms like principal component analysis, linear discriminant analysis, like things. So this is one of the machine learning algorithm. And there is gradient boosting algorithm. That is again the combination of distant trees, but in different manners. And the very important and very romantic, I say romantic type of algorithm is artificial neural network. Now onward, I will be mostly talking about neural network only, because deep learning is all about neural network. So, what is the most crucial part of the learning? So, anybody can tell me which part is the most crucial part for learning? Very good answer. Feature extraction is very crucial part for learning. So here comes deep learning. Now in the deep learning, there is no feature extraction. We can learn directly from raw data. Raw image pixels, raw text, raw audio. No feature extraction. So the idea of deep learning is to simulate the brain. When we learn, we do not see the features. If we have to learn this is the there, we do not go for its age, its height, or its width like this. We directly learn this is the chair. If we see this is 2-3 times, we can define this is chair. So deep learning is a very similar concept. It learns directly from the raw data, and it simulates the brain. And okay, I will tell you later. So the idea of deep learning is to simulate the brain, but we even still don't know how the brain works, but we are simulating the brain. So here the hope is to make the learning algorithms much better and easier to use, and make some revolutionary advances in machine learning and AI. So there are two big ideas behind deep learning. One is it can learn multiple layers of representation. It is actual internal brain representation. When you learn certain thing, or when a child learns some letters, some structures, there is a level of representation for it. So we are applying the same rule in the deep learning to learn the representation, feature representation. Another is learning features from unlabeled data. So why we need deep learning? Because now we have more data. We require bigger models and we require more computation. The goal is to achieve better results. To achieve better results, we require more data, we require bigger models, we require more computation. So better algorithms, new insights, and improved techniques always help. And here, when you go for traditional machine learning approaches or algorithms, if the amount of data increases, the accuracy remains constant. It do not increase further. But for deep learning, if data grows, the accuracy grows. So now I'll be talking about some of the recent achievements with deep learning. These are again the problems of AI, and you can say applications of machine learning. And here, the deep learning performs above all the traditional machine learning tasks. The first application is automatic colorization of black and white images. The task is to color the image, the black and white image or monochrome image. We have to color it. You can see in the first picture it is colored by hand, but in the second picture you can see this is automatically colored by the deep learning algorithms. So how can it be done? Machine learning. This is we can say directly it's deep learning. Deep learning can be used to use the objects and their context within the photograph to color the image, much like a human operator might approach this problem. Actually, how this is done. There is one ImageNet organization. They have collected lots of images over the world, and machine learning, that deep learning convolutional neural network is trained on them, like AlexNet or GoogleNet, like deep layered neural network are trained on those data, and they represent, or they learn the representation, they learn the colors, they learn the information from that data. Then they transfer that knowledge to colorization program. So this knowledge transfer is also one of the top trend today in the deep learning. Learning in one domain and transferring that knowledge to different domains. Again, let me give you one example. Suppose This can be helpful for like somebody is very good in sport, and if we can take the learning procedure or the that capability of that brain and use that brain, that capability to in another person, then the learning in another person is better. So that is knowledge transfer, and similar concept is applied here, and very good results are applied. Found here. I have put some of the research papers here. These are the most recent papers, 2015-16 like papers. And under application of deep learning with great achievement is automatically adding sounds to silent movies. So it is also a very complex, very complex problem, but achieved very good results with deep learning. Here, the system is trained with using examples of videos with different sound. A deep learning model associates the video frames with the database of pre-recorded sounds in order to select the sound to play their best matches with what is happening on the scene. So it is given a blind or muted video, and the system will generate the sound for it. So here again, if we go for the evaluation of this system, how accurate is this system? They developed one Turing test like script that is, and they show it to users either this is acceptable or not. Then it can be said as intelligent or not. So you can see live demo here. So I'm not going for it now. Okay. So it is also very recent research on deep learning. And the very important, very good application, very useful application of deep learning is for this solution. Automatic machine translation. We can see Google Translator today, or voice recognition today is very complex and have good performance. So the task is automatic translation of text, automatic translation of images. Text translation can be performed without any pre-processing of the sequence, allowing the algorithm to learn the dependencies between words and their mapping to a new language. It is a little technical term. Here the recurrent neural network or the LSTM neural networks are used, or sequence-to-sequence learning, deep learning methods are used to learn this. To find a solution for this problem. So if you have to translate Nepali language to English, then we can directly translate or directly can apply this on the raw data without any pre-processing. So another instance, visual translation is finding the text on the image and translating it to other language. So here also references are very new, recent, 2014-15. So actually, this deep learning advancement is after 2008 and mostly after 2012. And the very complex problem of AI that is solved very well by deep learning is object classification and detection in photographs. So here the task is classifying the object in the photograph, but that classification is done based on previously known objects, and that is one of the problems. Another is the detection problem, very complex problem. Detection means detecting particular object and localizing that, or finding bounding box over that. We can see again references are very recent. You can see 2012, 13, 14 references are there. So another achievement is in face recognition. It is when I started deep learning in 2014 that Facebook has released this deep face network, and they trained it on 4 billion like images with 4,000 people, and they achieved 97.35% accuracy, and they published their paper online. So we tried to make the same system with our data, but we are not to that level because we do not have that much data at that time. So this is the deep face from Facebook, and after 1 year like that, Google has released this FaceNet. This is also a very deep neural network architecture to recognize faces. It is actually has recognition, clustering, and verification, all three in one model. So it is a very deep neural network, convolutional neural network mainly to achieve these goals. In 2014 and 15 research. And then a fun example of AI or achievement today with deep learning is automatic handwriting generation. Though it may not have much application in real life, but it is fun example and good achievement because here the system can write for you. You give text, words or phrases, and system writes for you with different writing styles. Here, learning can be done with some previously recorded online learning samples, sequence of samples. Okay, then there is another example of automatic text generation. It is also very good achievement on the deep learning or machine learning field. It will automatically generate articles or text. So you can write. Suppose if system is trained on all Nepali news sites, then from tomorrow it will start writing its own news. So this is one of the very interesting, fun example. I also have tried this. Okay. So another very good achievement and very useful achievement in machine learning with deep learning is automatic image caption generation. That means system will automatically describe the image. So here mainly two deep learning techniques are used. One is convolutional neural network for image feature extraction, image representation, and one is recurrent neural network or LSTM neural network for find this description representation. And then most good achievement in AI deep learning is automatic game playing. In the first figure, you can see that there is a deep blue machine and Gary Kasparov, that is world champion for chess, and deep blue wins over there. So, and there is recent publication from Google DeepMind team that this AlphaGo, very popular Chinese game, is won by this AlphaGo computer, deep learning computer. Over some Chinese player. So there are lots of other problems or examples of AI that deep learning has very great achievement on it, like automatic speech recognition, automatic speech understanding, automatically focus attention on object in image. Actually, automatically focus attention on objects in image is where we have to mostly apply most computing power in the image. So not all the areas are important for computation. So when the most information we require, then we apply most processing here. So automatically answer questions about object in photograph, what is behind this, what is in front of this slide. So automatically turning sketch into photos and automatically creating the artistic images. So those are some of the achievements with deep learning. So I'm now concluding the presentation and going through certain trends today with machine learning, deep learning, and artificial intelligence. This is the Google trend of search terms like artificial intelligence, machine learning, and deep learning, and it is increasing from last 5 years. And later one is Google Scholar chart that shows the articles published over last 5 years. So there are lots of advancements in machine learning, AI, and deep learning. So there are top companies who are working on deep learning field or machine learning field, like DeepMind. DeepMind is actually acquired by Google, so it's Google company. Second Google, then Facebook, then OpenAI. OpenAI is mostly for reinforcement learning and gaming research. And then Baidu, and then Microsoft Research, then Apple, IBM, Amazon. Actually, IBM, Amazon are quite secret in nature, so mostly above companies are in the ML today. So there are top machine learning experts in the world, like Jeffrey Hinton. He is at Google Brain Team today, and he is the inventor of many deep learning technologies. Like Michael Jordan, he is professor at UC Berkeley. Andrew Ng, you probably have heard about him. He is a machine learning hero. And there is Jeff Hawkins, and there is Jan LeCun. Actually, he is at Facebook, and he started with LeNet is there, that is handwriting recognition network. He invented that. Terry James Key, David Dolphy, Jubin, and Sebastian Thaler. These are the top experts in machine learning today. Actually, deep learning. So here are certain libraries you can use if you want to start with machine learning or deep learning. Spark ML library, that Java, actually Scala based, Python R is there. So you can start with it. Scikit-learn is there for Python. TensorFlow is there for C++ and Python. NLTK for natural language processing in Python. Torch is there for Lua, that is computational language, and C. Deep learning 4J is there for Java and Scala. Now they are on the Spark also, I think. Theano is also there. Cafe 2 is also there for C++, Python, and MATLAB. When I started deep learning with face recognition, I started with Cafe, and then there is DDeep is there, and there is MLBank. It is not quite maintained ML library for C++, but it's good also. And there is Stanford Core NLP for natural language processing, and most of the core natural language processing algorithms are there, like POS tagging, name tagging, coherence resolution, time resolution, etc. There is Marriott, there is Weka, which is most widely used still today, has lots of machine algorithms incorporated in it. And there is for NLP is Apache, OpenNLP is also good. Another trend is MXNet. MXNet is powered by NVIDIA, Microsoft like those, and it has wrapper for Python, R, Julia, Scala, Go, JavaScript like that. And these algorithms you can find on GitHub also. I've taken from here. So, and last, the conclusion. So, what is the conclusion now? What is AI? What will be the next thing with AI? Or what will learn? So nothing. Simply, AI is the new electricity now. It will power the industry. And this sentence is said by the Andrew Ng, not mine. But AI is the new electricity now. Okay. These are my publications. Some of my publications from IEEE and global journals, mostly on handwriting recognition, number plate recognition, movie review, sentiment analysis, like that. Other my own projects, not published projects are there. Lots of projects are there in computer vision, natural language processing, data mining. So okay, that's all. Thank you. Any questions you can ask?